Hello, let's do the New York Times hard Sudoku for June 11th, 2023. I'm going to hit restart so my time is accurate. Okay, how do we want to start today? I am seeing this immediately. I'm seeing a few of these where there's 3 givens in a box, and then the other column is open, and that's usually a signal to look at the rest of that column because we need 4, 6, and 9 in this column somewhere, and they can't be here. So 4, 6, 9 need to go in these 4 cells. Now, if that were 3 cells, then we could immediately fill them as a hidden triple. But okay, what I'm seeing is that 9 is actually hidden in the column though, because, which I didn't actually realize when I started explaining this. I was going to explain it as not a good example, but at least we found the 9. You can see the 9's looking in. This 9, and this 9 look in. So it's always worth just like doing a quick scan of these, just to see if that trick has been planted at the start of the puzzle. 6 can't go here, but 6 could be in either of these, and 4 could be in any of them. So we can't continue with that, but we have the same thing here, 1, 3, 4. 4 is already in the row, so we have to kind of ignore that and look for where 1 and 3 go in this row. I see a single 1 and 3 looking up, so it's not as useful. Then we have 5, 6, 8 here. We have it a ton in this puzzle. That's why I wanted to just start with this. The 6, unfortunately, is already in the column, but we do need 8 and 5. Okay, well, at least I'm seeing the 5 isn't here, right? So 5's not in any of these. So 5 is down here, which is actually good to note because of the way we found it through the column. It means that we have some legitimate, at least from these two, legitimate eliminations of 5 from these two. If either of these was 5, then there would be nowhere to put 5 in this column. So these are not 5. And that is not an obvious statement. And so it does mean 5's up here. Okay. Any of these other ones. We have 1, 3, 5, 9. The 9 doesn't count, but 1, 3, 5. Oh, the 3 doesn't count either. I was about to say we have 3 open spots, but unfortunately we already have a 3 in the column. But 1 and 5, this can't be 5. So we have the same thing going on here where this can't be 5. So 5 is down here, and then 1 also can't be up here. Oh, okay. So this cell sees 1 and 5. So this is exactly what I was talking about. 1 and 5 are down here. This is a hidden 1, 5. So what do I mean by that? 1, 5 hidden. It's a hidden pair using Canon's 1, 5, which I would normally call a hidden 1, 5 pair. So this column needs a 1 and a 5 in it, right? The Sudoku is broken if it doesn't eventually get a 1 and a 5. And so where can they go in this column? Well, this cell sees both 1 and 5, so they can't go here. And these 3 cells see this 1 and 5. So, and this is a 9, which is notably not 1 or 5. And so, also the 4 and the 3. Anyway, we're down to 2 cells that can contain 1 and 5. So if we tried to put something other than 1 or 5 in these cells, we'd end up with a single cell that had to contain both 1 and 5, and that is not possible. So this is a 1, 5 pair, even though there could be other digits, like especially this one. There could be plenty of other digits to fill. It's not. It's only 1 or 5. Anyway, that is a hidden pair, which maybe especially, it's not actually useful in eliminating anything for this column because we found it through the column, but it does eliminate both 1 and 5 from the rest of this box. 5 was already not here, but 5 is now out of here. Sorry, 1 and 5 were already not here because they're in the column. But 5 is not here, which again is a non-trivial deduction. 5 is also not here. 5 is also not here. So 5 is in one of these two. All right. Let's see. We would have found that from scanning, hopefully, but anyway, I found it a different way. Let's see if there's any more of that going on in this puzzle. We have 8 and 9 here, 3 and 4. Usually when it's only 2, it's more difficult to find something, but and when the row is so open. I am wondering about this column because it does only have 5 cells left. So is there any hidden in the column is the question. These two see a 3. This sees a 4 and that sees a 4. 7s? No. Okay, I'm not seeing a hidden. So no luck there. We do need 3 and 4 in the column. And I notice Actually, we need 3, 4, and 8 in the column. Oh, actually, is there just is this a naked single then? I think this is a naked single. And the reason I say that is because, look, we've got 3, 4, 7, 8, 1, 2, 6, 9, all looking at this one cell. That's 8 distinct digits, right? The only digit missing is 5. So this is a naked 5. And that gives us this 1 and 5, which gives us this 5. Look at all that. I bet this isn't how you started the puzzle. I'm having fun though. Let's see, we've got, so you don't need massive markings to find this stuff if you look at the geometry of the grid, which is what I try to reinforce, but I'm trying to get better at it myself. I think this is really good practice for that, because I tend to hide stuff like that in these puzzles all the time, on purpose. I'm going to fill this triple because I always like filling triples. This is 2. Despite having just said don't fill everything all the time, triples are great to fill. And we just found a naked 2. The 6 and the 9 looking down makes this a 2, and then we get 6 and 9. So this whole row is done. So that was definitely worth filling. We could have found that through finding that 6 and 9 couldn't be here, but they needed to be in the row. But when you're down to 3, just filling the candidates is often the way to go to speed things up. I am still curious about this column though. Let's think about exactly what digits it needs. In fact, I'm going to fill what digits it needs because it is 4 left, and that seems like it could be helpful. When it was 5, I wasn't willing to, but we need 3. Ooh, they're not all the same digit. We need 3, 4, 7, 8. Okay, so I eliminated a 4, a 3, and a 7, just a single of each, so that's not going to be helpful. Yet. All right, I actually haven't done my normal scanning yet, but let's see if we have any more of these interesting. Okay, so I'm seeing 3 isn't here, so 3 is down here. Let's see if there's any other interesting geometry, because I kind of stopped somewhere. We got 1, 7, 5, 9. The 5 isn't interesting for this row, but the 1, 7, 9 are. Not interesting enough though. 1 is over here just for normal scanning. 9 is as well. 9 joins the 1. It's not in the middle. We don't have another digit yet that joins them though, because 7 could be over here easily. Okay. 1, 9, and 5 are easily in this column already. Well, I've got 5, 9, and 6 that I do need to place in this column. This can't be 6 or 9. And it can't be 5, actually. Yes. Okay, here's another one. We've got 5, 9, 6 in this box. They can't go here. And this sees 5, 9, and 6. So this can't be 5, 9, 6. So this is going to be a naked single, but we can place 5, 9, 6 up here because again it's 3 cells. Actually, we can place the 5 apparently. We can just place all those digits, and then now we can place this digit, I think. Well, this is going to be a triple, so let's see what happens. We have 2. We have 3. Sorry, we need 2. We have 3. We need 4 and 7. Okay, so I was wrong about that because I forgot about these 2 down here. But yeah, these had to be 5, 6, 9 because I need 5, 6, 9 in the column, and they couldn't go in these cells at all. So they had to be in the remaining 3. This is a triple remaining. We have 2, 7, 8 here. So okay, so this is what I call a satellite situation. So I have a triple, 2, 7, 8 triple, and 2 of them are kind of, one of them's kind of off and different than the other 2. In this case, these 2 share the same, they're all in the same box, and these 2 share a row, and this one's in a different row. And this one's missing the 8. So we're going to have to put an 8 in this triple somewhere. The triple contains 1 each of 2, 7, and 8. And so, and I'm just showing you how I would see it. You could also see it as just in the box. But even in a case where there's a triple that isn't limited, isn't the remaining triple in the box, you can still see, if you notice the satellite cell, you can immediately just think about how 8 is limited to these 2 and how that eliminates 8 from this one. Because if this was an 8, there'd be nowhere to put 8 either in the box or in this triple. But I was thinking about it as the triple. The triple needs an 8. So yeah, those satellite cell situations can be quite useful to just quickly spot when something's limited, when you might not have noticed it before. I'm seeing that 9 has only one spot in this box. I actually did not do any of my normal scanning at the start of this, so I might have a bunch to get just from that. This is not a 9, so this is the only place for 9 in this box. I may have accomplished a lot of my normal scanning just from doing it in a different way, but like these 5s I didn't find, for example. So yeah, unfortunately, like this would have been a prime candidate, but let's see, the 6 and the 9 and the 5 are already in the column. The 8, that means the 8 is in one of these two, but we can't limit it that yet. But it was down to 1, it would be a hidden for the column, which would be great. This 4 looks down, so 4 is in one of these two in this box. The 3, the 1, okay, we already have 1, 3, 5, 9 in the box, so that's unhelpful, unfortunately. But this cell here, 2, 7, 8, that's going to go here. It's not a 2. There's probably an alternative way to see this, but actually this could go here as well. Hold on, I've got 1, 3, 5, 9. Yeah, okay, the 4 and the 2, 7, 8 are gonna have to go here. So this could be 2, 4, 7, or 8. I cleared a 4 corner arc by accident. So it actually does, this is 4, 7, 8, yeah. And that's probably just Sudoku right there. Just what it could be. It can't be 1, 2, 3, 5, 6, 9. Yeah. All right, this is going to be a quad for this column. Let's fill that as well. So we need 2. We have 3, 4, 5. We need 6, 7, 8. Okay, it's basically what I expected to happen, but all right, let's keep scan. Let's actually just scan the rows right now. We have all the 6s. Okay, 1s. Don't see anything with 1s. We have 2 4s here. We have 3 4s, and that's enough to place a 4. Oh, I should probably do this top row, but let's scan these first. 5s we got. 6s are done. We don't know anything about 7s. I'm gonna just pencil this. It's a triple. We need 2, 7, 8. This is a naked single 8 because it sees the 2 and the 7. And that leaves a 2, 7 pair here. Sure, let's fill this. Let's just fill all of it. I need a 1, 2, 3, 7. And we know that 7's going to be like super available because there's just the single 7 in the grid. Okay, here we need 1, 2, 3, 5, 7. This is quite limited. In fact, this is a 1, 3, 7 triple here. So that means none of the rest of the row can be 1, 3, or 7. I had a question from someone the other day, and I did answer it, but don't triples need to have the 1, 3, 7 in each cell? Well, one argument I could make is, sure, let's add that. Okay, now it's a 1, 3, 7 triple. Even though it can't be 1 or 7, like, why would eliminating a candidate change the logic, right? It can only make it stronger. It can't make it weaker. But another way to put it is we need to put, these cells need to be filled with digits, right? We're going to have to end up with digits in these cells. And there are only in total 3 possible digits, 1, 3, and 7, to put in those 3 cells. So they must be put in those 3 cells, which means they cannot be put in other cells in the row. So that leaves a 2, 8 pair here, and that places this 7. I figured I'd explain that because if I got the question, then someone who's less vocal probably has the same question. All right, so 7 and 6 are down here. That's another satellite situation. Here I have a quad. 3 of them share the same box, and one of them's, it's a one of these things is not like the other situation, right? It's easy to recognize just by looking. And we see that this one is missing the 6 and 7 for the quad. So the 6 and 7 go down here. And that's actually interesting. Finally, I get an elimination from that. So the 7 is here, the 6 is here. It means this can't be a 7. If this was a 7, there'd be nowhere for 7 in this column. So we can eliminate that 7. And that makes another situation here where 7 goes down here, another satellite situation. Once you start seeing it, they're kind of the gift that keeps on giving. You could have seen that logic in a different way usually, but it's so nice to just quickly recognize and quickly know, okay, anything that's not 2-8, that's going to be down here. Like, we're all about ways to holistically look at the grid, right? I actually only scanned this top 3 rows so far in earnest. So let's see what else we can find. I do think I may have just incidentally found most of the stuff to find, but okay, I'm seeing 2s in one of these too. Well, I see it because I saw these 2s. 9 is placed everywhere. Okay, I was looking at rows. 9s are done. It's just there's not much to see here. How about down here? These are pretty close to done. I might give it the full candidate treatment. They all have 4 left in their boxes, so we're likely to find something. We have 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay, this is a 7. This can't be 1, 2, 3, 4, 5, 6, 8, or 9. So it is a naked single 7. That makes this a 1, an 8, and a 6. That places this 7 that we have marked up. Remember, we did that from our satellite situation. We've got those marks from that, and they're immediately useful. Here we need 2, 3, and 4. This can't be 2. So another satellite situation causes 2s to point here in this box. They point left, but it doesn't actually matter because there's already a 2 in the box. But this is a single because I see that we have all these digits filled and then these form a pair. So this has to be whatever's left over. Just by counting how many digits there are in the row, which is 9, and then seeing that this covers 8 of them. Although you don't have to prove that in your head every time. You can just sort of see that there's an empty spot. All right. Cool. I feel like we're almost done, to be honest. This was a fun solve today. I feel like I'm 17 minutes in, so I'm not faster, but I feel like I explained some cool things today, which I enjoy. That said, I'm not victorious yet, so let's keep going. This is 1, 3, or 7 for the column. Can't be 3, so it's 1 or 7. That means 3 again. We have the satellite situation. 3 is up here. This cannot be a 3. I was hoping for a 1, 3, 5 triple, but 2 is interjecting itself. This is just a triple for the column, so let's fill that. We need a 2, 4, and 5. Keep an eye on that. Keep an eye on that. Like we're always looking on the lookout for, like, when we fill something vertically, we should be on the lookout in horizontally and in the box to see if that made anything interesting. So we don't have to come back and rescan it. Here, this 1, 7 is going to be a satellite on these 3, because this is a 2, 4, 5 triple and a 6, 9 placed. So what we have left is 1. We have the 2. We need 3. We have the 4 and 5 and 6. We need 7 and 8. And what we know is that the 3 and the 8 are limited here. Unfortunately, we don't have any eliminations from that, but it's a nice to have these corner marks for when stuff gets eliminated and we can more quickly finish the box without having to rescan it. These do not look super interesting to me. Oh, I am seeing 1. Wait, no, I was imagining there was a 1 up here, but it was a 6. In the corner of my eye, I was hoping that this was 1, 9, and 1, 9. Okay, this can be 1. I was thinking if this couldn't be 1, then 1's over here in this row. Okay, I missed something in all of my pencil marking. It's gotten very busy, so I'm not surprised. Oh yes, this 3, 4 pair in this box places this 8. Let's look immediately at what that does. Doesn't look like it does all. Okay, 8 can't be here though. Okay, so 8's in one of these 2. Unfortunately, we've got a bunch of 8s left in the grid that could be placed. Yeah, that's going to need some help. This column has 5 left. We need 1, 3, 4, 5, 6. The only thing I'm seeing is this 1. It's all 1, 3, 4, 5, 6. Oh, and I guess the 6 here. So they each have 1 eliminated. One value eliminated, not the digit 1. I know that's confusing. And here we need 1, 2, 3, 5, 7. Did I miss something? 1, 2, 3. Yeah, 1, 2, 3, 5, 7. They can't be, okay, none of them can be 2. So 1, 3, 5, 7. That's all the odd digits apparently, except for 9. Yeah, we see 2, 4, 6, and 8. Okay. There's our 1, 7 pair. It's just hiding there. So yeah, as soon as I placed these, I scanned to the right and I saw that we got a 1, 7 pair. That places this 8 and a bunch of other stuff. Let's eliminate, yeah, so that this is a 4. Again, there's the 1, 7 pair, 2, and this is completely finishing the row. Well, except for the 1, 7 pair, it finishes the row. Here we've got a 4, 5 pair. These can't be 8. I'm doing my best to clean these up as we go, but I think at this point, I think we're going to just end up finishing the puzzle, so we don't need to clean up. Yeah. Okay, that's the 5, 6. Okay, I'm going to clean up a little bit. Oh, there we go. 7. Oh no, I broke it. Okay, maybe I went a little too fast. Let's look at this 1, 7 pair again. That's what undo's for. Okay, I'm gonna go all the way back to here. And I'm gonna make sure I filled this right. So the column needs 1. We have a 2. The column needs 3. It has 4. It needs 5. It has 6. It needs 7. Okay, this is not 3 or 5. That's not a 1. This is a 1, 7 pair. What's keeping this from being 3? This is. Okay. So the 1, 7 pair eliminates 7 from here, 7 from here, and 7 from here. The 1, 7 pair also eliminates 1 from here. So this is an 8, 4, 2, 6. These aren't 6. These aren't 8. That's not a 2. Okay, so far so good. These are not 4s. I feel like maybe I went and typoed a bit, but we'll see. I hope this doesn't end up exactly the same as what I did before. But if I broke the puzzle earlier than this, it'll break at some point. Even if it breaks somewhere else, just because the order I place things. It is quite possible that I just broke the puzzle earlier, like I made an incorrect logical leap of some kind. But I think probably what happened is I went a little bit too fast in placing these numbers, and I typoed something is more likely what happened. Because everything felt pretty methodological earlier. Yeah. So this worked out this time. Cool. So yeah, don't despair if you break. Just go back to where you think you may have made the mistake and try again. Cool. Well, yeah, I mean, this puzzle took me actually longer than most recent puzzles, but I feel like this was a great opportunity to talk about a different way that you can approach these puzzles. And especially the New York Times Hard loves hiding this stuff all over the place. We found like this 1, 5 pair, for example, was super cool, where there was just a 1, 5 pair sitting here in this column the whole time. And then there was like a hidden 9 here that was sitting there. And this hidden 9 would not have been easy to see if you just blasted the candidates on in every cell, right? But I looked at 4, 6, 9 here in this column, just knowing that they would be somewhat limited, and just immediately spotted these 9s, right? Which is not something that is easy to spot, I think. Hiddens in columns and rows, especially when they're this open, can be very hard to see. So very happy with this solve today. I am definitely going towards a more instructive angle here. I'm not trying to speed solve and just awe you. I am trying to help you improve and think about Sudoku differently. So I hope that I'm accomplishing that goal. And if you think I am, then why not leave a like, subscribe, kind comment below, and share it with a friend who wants to learn more about Sudoku. And I'll see you next time.